And we're back for the exciting conclusion of lenses and lens images. We have talked about converging real, converging virtual images, and now we're going to the third type, where instead of a converging lens that takes the rays and converges them down, we have a diverging lens. Diverging means light rays that come in get spread out. We still have two curved surfaces, which means that we still have two focal lengths. But just like with convex mirrors, where the mirroring is on the outside, light rays that come in get spread out, so the focal length is a virtual focal length. The focal length kind of has to be traced backwards, which means that just like with convex mirrors, the focal length for a diverging lens is negative. It is virtual. We're going to have the same three rays, and we just have to be careful about how to treat them, because now we have two focals. It was a little easier with convex mirrors. This is the one that's a little harder. But if you can remember that the rays always have to spread out for a diverging lens, you should be able to get it figured out. Just remember that. When the light comes in, it has to go out. So, diverging. This one, I can recommend starting with the easy ray. Just go straight through the center. Give us that one to start with. Wow. Okay, so we have the light ray that goes through the center of the lens, and that's going to come out here. The reason that I like starting with that one for diverging is because then I know if I do a ray and it meets this one, it crosses this one, it's the wrong ray, because these have to spread out. They can't converge. All right, so what are the rays? We have one that goes out parallel and then through the focal. Start it off. We go out parallel to the axis, something like that. And then for a converging lens, we would go through this focal because it converges down. Diverging lenses, we have to spread them out. So what we do is we use the back focal. We use this focal instead, and that tells us the direction of the ray that gets spread out and diverged. So there is our diverging ray. Third one. The third one is for a converging. We would go through the focal and then out parallel. Okay, so we're definitely going to go out parallel, but instead of going through this focal, which would cross this line, we can't do that because we can't have any converging lines. Instead, well, I've already used this focal and I've used the center. I must still have to use this focal. I'm going to line up with the far focal, and then as soon as it hits the lens, that's where it shifts, and we now go out parallel. I can double check that it makes sense by saying, okay, do these three rays diverge? Yes, 1, 2, 3, they're all going in different directions. Which means we're going to backtrace, which means we have a virtual image again. You can see that they're going to meet up around here somewhere. And I can do my back tracing. Orange goes back down. Remember, it's always the rays that leave the lens. So this one is going to be back traced back to that focal. The line here is going to just go flat out. All right, so we're just going flat, flat, flat. And then the center, look at that. I don't have to do it anymore. I found it. Right here is my object. Here's my original, I just said that wrong. Here's my object. Here's my image. Okay, so my image is formed here. This is a virtual image again, because the light rays don't actually meet up there. Your brain says, oh, if my eye is here, it thinks the object is somewhere on this line. And so it thinks the image is there, but you put a screen there, you won't see anything. What else? It looks smaller this time, and it's pretty close to the lens. Yeah, okay. Let's do our math and see if we get close to the other ones. I find that the diverging tends to be good on the math. And now watch, it's going to be totally off. So DO and F and then DI calculated, DI measured. What is my DO, my object? Not long enough. Oops. How about that one? Okay, oh, look at that. I set it up at about 30. My DO, and remember that DO is always positive no matter what. Doesn't matter where it is, doesn't matter what else happens, your DO is always positive. My focal length, that one is negative, and in this case it's set at -20. All right, calculate DI. 1 divided by 1 divided by the focal, -20, minus 1 divided by DO, 30, and I get a DI calculated of -12. Negative is good, because it's a virtual image, so I should get a negative. Let's see how close it is. Let's see, line that up. Oh, right on. Right on. Measured, -12. And this one, this negative, I have to put in there myself, because I know it's virtual, so that has to be negative. But the picture doesn't, well, the picture does tell me that it's a negative DI, because you had to backtrace. The math comes out with a negative on that one. Once we have DO and DI, we can get our magnification. So minus DO over DI, oh, they're the same. Wait a minute, yep. Okay, that should be positive, yeah. A little over 2, 30. I did something wrong. There we go. Okay, I knew there was something going on here. DI over DO, I had the wrong equation. Let's try this again. Magnification is minus DI over DO. Minus 12 over 30 gets me a positive 0.4. Magnification, positive 0.4. Positive magnification, upright. Yep, they're both above. 0.4, less than 1. The image should be smaller. Yeah, a little bit less than half. Sure. We can finish off by calculating and measuring our image height. HI measured. So let's see what we've got here. Centimeters. 15, 16, 17. And that's positive because it's upright. HI calculated and HI measured. Let's do the calculated first. See what we should have. So magnification times HO, 0.4 times 17 gets me positive 6.8, so about 7. Let's see if we're close. 7 centimeters. Ooh, yeah. So, yep, from that line there to the blue line is 7 centimeters. It's upright, it's above, I should say, so I get plus 7 centimeters. It all worked out. Good, and then just to remind you, this is virtual because it doesn't actually exist. It is only in your head that an image is formed there. Diverging tends to be the one that gives people the most trouble with lenses because we kind of flip-flop which focal length we use. But if you can remember that diverging lens have to spread out, then you can kind of say, oh, I think I know which one I did wrong, because these always have to just be going away from each other. If you get any two that cross, you know you have something wrong. If you look at the ray tracing, you can also see that diverging lenses will always produce a smaller upright image. There is no way that you can have a line go to here and then along here that's going to be taller than here. So diverging lenses always produce virtual images, they're upright, and they're smaller. So that's, if you're good at memorizing patterns, that's a pattern that you can keep in mind for checking your answer. So this will always be positive, smaller than 1. All right, that's part number 3, converging real lenses, converging virtual, and now diverging virtual. That is all 3 types of lens image formations. All right, good job.